Hey everybody, welcome to an algebra video on factoring. Hey, you're going to like this one because guess what? Today we're going to be talking about a shortcut to factoring. So just for quick review, let's talk about what we've already learned. Every time you look at a polynomial, you need to consider, is there a GCF? And you think about, can I take out a negative? You wonder, is there a common value in every term? Maybe there's a common variable in every term. And you want to make sure that you address those. So if you want to, we can go ahead and look at something that looks like this. 2x squared minus 10x. Could you classify this polynomial? That's right. It's a quadratic because we see the 2, and it's a binomial because there's two terms. And this one has each of those considerations above. So when I think about the GCF, I think about what value I can take out of each term. A negative 2x can come out of each of these terms, leaving me with an x and a plus 5. We consider this factored because here's one and here's another factor. We've introduced parentheses, and it's not simplified. So that's what we're doing when we're factoring. We're breaking things down into the pieces that are multiplied in order to get that. All right, your next strategy that you learned was about grouping. And you learned about that with 4 terms. And in this week's video, you talked about it with 3 terms. And guess what? We're going to build upon that and talk about a shortcut that we can all use. I want you to think about this quadratic, so you know it has a squared, trinomial because it has 3 terms. And when you look at this quadratic trinomial, 2 things can be multiplied to get this. And when you look at it, I don't see a greatest common factor. This doesn't have any variables, and there are no friendly numbers between 10 and 5. But there is a way to break that down. And with the grouping strategy, we talked about doing the number puzzle, finding 2 numbers that multiply to 10 and add to 7. So whatever strategy you use to make this work is up to you. I like to draw a factor table for 10. And I think about all of 10's friendly numbers, 1 and 10, and 2 and 5. And I'm looking for this sum of 7. And if you notice, I found it right here. Now, if you struggle with your math facts, feel free to grab a TI calculator or Desmos. Because what you can do here is go ahead and into your y is equal to, you can enter 10 divided by all the numbers in the whole wide world, and that's the X button that's right here. When you go second graph or go to the table button, you can see all of 10's friendly numbers. And if you look at my chart, you can see I found the ones that go in evenly. 1 goes into 10 times, and 2 goes into 10 5 times. So in this week's video, you learned how to rewrite this 3-termed polynomial using these 2 terms. And then you were back to familiar ground by grouping, drawing a box, finding the greatest common factor from each of these boxes. So we can take an x out, and that leaves us with x plus 2. And we can take a 5 out, which leaves us with x plus 2. Once we see this common happy face, we know that that can be divided out. So when I pull out my x plus 2, I'm left with an x for this term and a 5 for this term, leaving me with x plus 2 times x plus 5. These two binomials multiplied together give me this trinomial. And right now you're like, hey, wait, I thought she said there's going to be a shortcut. That doesn't look like a shortcut to me. Well, here it is. When I look at the quadratic trinomial, I know I'm looking for the two binomial pairs that can be multiplied. Now, this trick, for the most part, is best used when we have a coefficient of 1. This is our A coefficient here. And when A is equal to 1, we can go ahead and use this shortcut. And here's how it works. Are you ready? We're going to unfoil this quadratic. I know that x times x is x squared. And when I foil, those are my first terms. So when I looked at the answer I got here, x plus x is x squared. So if I work backwards, if I split my x squareds, I can put an x in each of my parentheses. Okay. Now let's look at this back number. I know that this number here is the product of these two last terms. So this, whatever goes in this box, and this, whatever goes in this box, when we multiply them together, give me that 10. So I'm going to go back and guess what? Make a factor table. 1 goes into 10 10 times, and 2 goes into 10 5 times. So I know I need the two numbers that are going to multiply to 10, but I also need them to add to 7, because when I have my first terms and I have these last terms, I also need to consider what happens when I have my outside and my inside terms. And that 2 and that 5, when I add them together, will give me my outside terms. My first terms, x times x is x squared. My outside terms, 5x. My inside terms, 2x. They add to 7x. And then my last terms. So I'm using the numbers from my factor chart or my number puzzle. And instead of rewriting the factors and doing all the factoring grouping, when I have 1, guess what? Those are my values that go into my binomial pairs. Now we're going to do a bunch of samples of these, and we're going to really spend some time talking about our signs. Because if our signs match in our binomials, that's going to give us a positive product. If our signs are different in our polynomials, that's going to give us a negative. Paying attention to these signs helps you know whether this middle term is a sum or a difference. All right. Are you ready to go? Let's do some samples. All right, so here's example number 1, x squared plus 21x plus 20. So I'm going to go ahead and look at my number puzzle. I'm looking for factors of 20 that add to 21. So remember, this is our sum and this is our product. If I want to think about 20, I'll go ahead and draw my factor table. I know 1 goes in 20 times, 2 goes in 10 times, 4 goes in 5 times. If those are not friendly numbers for you, remember you grab your calculator, turn it on, you go to your y is equal to, you type in your number divided by all the numbers in the whole wide world, or x. You go to your table of values, and you can see each of these friendly numbers, 1 and 20, 2 and 10, 4 and 5. Remember, I'm not going to continue writing any repeats because guess what? My commutative property takes care of that for me, and I don't have to worry. I can just circle around the table. If you want to use Desmos, you can type the same thing into your Desmos and it'll give you a graph, or it'll give you a table with the same values. So do you see which two set of numbers multiply together to give you 20 and add together to give you 21? Yep, I see them too. So I'll start off by drawing my parentheses. I'll split my x's, one here and one here, because x times x is x squared. The number that I saw that made sense to give me that sum was 1 and 20. So I know that 1 and 20 complete my number puzzle. So I know that 1 and 20 are my values. I'll go ahead and look at my signs, and I know that my product is positive, so my signs match. And I know that my sum is positive, so they're both positive. Guess what? You're done. If you wanted to double check it, of course you can FOIL, and then you can go ahead and see that your first and your outer and your inner products plus your last are going to give you x squared plus 21x plus 20. So yes, this checks, because I was able to factor, and then I was able to FOIL to check. All right, let's try another one. All right, we have this quadratic because of the squared, trinomial because of the 1, 2, 3 terms. I'm going to do my number puzzle, and I'm looking for two numbers that multiply together to make this last term and add together to give me 17. Remember, this is the sum of my O and my I, and this is the product of my last terms. I can set myself up for success by going ahead and drawing my parentheses, knowing my x is split. This works, don't forget, because I have this coefficient of 1, so I don't have to worry about that coefficient, and I know that my x's, x times x is x squared. So I'll come on over and I'll do my factor table. Now 72 is a pretty tricky number that's kind of high up there with a lot of factors. So if you want to jump right to 72 divided by all the numbers in the whole wide world, there you go. And we'll go ahead and copy them down. 1 goes in 72 times, 2 goes in 36 times, 3 goes in 24 times, 4 goes in 18 times. I'm not going to write 5 because that does not go in evenly. 6 goes in 12 times, and I'll keep going down. 8 goes in 9 times, and you see right here I loop around. So thanks to my commutative property, I don't need to list any more factors. I have them all included here. So when I try to find two numbers that add together to be 17, there you go. Here they are. It's a good thing I made the whole list. They were the ones at the very bottom. So 8 and 9 are my numbers that work. So 8 and 9 give me a product of 72. This is positive, so my signs match. This is positive, which means that they are both positive numbers. All right, let's go on to our next. So there's something different about example number 3. Let me know if you see what you think might be different about this one. Yeah, you got it. Check it out. Now we have this negative sign here. But I want you to think about it. Our product is still positive. So when I go to draw my parentheses for my two binomial pairs, my signs are going to have to match. So I'm going to have a positive product, but I have a negative sum. So when I look first and I split my x's, does it make sense to you that both of those signs are going to be negative? Think about why that's true. All right, so we're going to go ahead and focus on our constant term, and I know that I have a product of 30 and a sum of negative 11. So I'll go ahead and I'll look at my factor table, and when I look at 30, I see 1 and 30, 2 and 15, 3 and 10. 4 doesn't go in evenly, but 5 does. And then, of course, I'm not going to continue because 6 is my next number, and that's my wraparound. So I can go ahead and think about that. So here's something interesting. Because both of my numbers here have the same sign, I'm still looking for a product, and I'm still looking for a sum. Those sums are just now going to be negative. So my 5 and my 6 are still the values that I'm looking for, but when I plug them in, notice they're now negative. I can check that if I want. First term's x squared. Outside terms, negative 6x. Inside terms, negative 5x. They add together to be negative 11x. Negative 5 and negative 6 multiply to be positive 30. I'm in good shape. All right, let's try on the next one. All right, so check out this. Now, I know you're curious. You're like, hey, I thought you said that this was a shortcut when our coefficient on our x term was equal to 1. And I said, yeah, but guess what? You still always have to look for what? Do you know what it is? You got it. It's the GCF. So when we find the GCF, we can look here and say, oh my goodness, I can take a negative and a 2 out of each of these terms. So when I take a negative 2 out, that's like dividing each term by that negative 2. And that's going to leave a positive x squared, a negative 9x, and a positive 36 divided by 2. Grab your calculators if you need to. That's going to be 18. Now here's the thing. When they ask me to factor completely, he still counts. So I can't just get rid of negative 2. We have to hold on to him. But that doesn't stop me from doing my same shortcut. Take my x squareds and I'm going to split them. Because x times x is x squared, I can split 1x for you, 1x for this guy. All right, now I'm looking for two numbers that fit my number puzzle. I want two numbers that multiply together to be 18 and add together to be negative 9. So let's go ahead and do our factor table for 18. And we'll think about 1 and 18, 2 and 9, and 3 and 6. 4 doesn't go in evenly. 5 doesn't go in evenly. And then I'm back to 6. So we'll just leave these three factors for 18. Now I want to know which add together to give me negative 9. Again, let's talk about the signs. Because this sign is positive, these two signs have to match. Because this is negative, I know that those are going to be negative because I'm adding negative terms. So when I go back to my chart, I'm looking for a sum of 9. Here it is. So when I have 3 and 6 in these positions of negative 3 and negative 6, I have negative 6x plus negative 3x. That gives me negative 9x. And a negative times a negative is a positive. So when I'm asked to factor completely, this factors into three different parts. The part I took out is my GCF, and then my two binomial linear expressions. All right, how you doing so far? Okay, so check out this one. In sample 5, what do you notice that's different about this one from any of the other ones that we've already done? You got it. Check it out. Now we have a negative product. And that's going to make things a little bit more tricky, but that's okay. We can handle it. I have a product of negative 12, and I have a sum of, think about what coefficient is on here. I have a sum of what? Positive 1. So I want to find two numbers that multiply together to give me negative 12. And I want you to think about that carefully, because guess what? The only way to get a negative is if I have two different signs. So when I start building my answer, my x's still split to x and x. But now that I know that I have a negative sign here, that changes everything, because one of these signs is going to be positive and one of these signs is going to be negative. That's the only way that I get a negative value here, is if these two values I'm looking for here have different signs. So, okay, let's go back to our factor table. 12, 1 and 12, 2 and 6, 3 and 4. And then because this wraps around, my next number is 4. I can stop right there. I have them all there. Now, here's what I want you to think about, and it's important for you to understand. Instead of looking for the sum, we're going to be looking for the difference between our numbers, because this has to be the difference between these two numbers. One of them is positive and one of them is going to be negative. And you know from your integer rules that when you have a positive plus a positive, you get a positive. When you have a negative plus a negative, yep, you just get more negatives. But when you have a positive plus a negative, or a negative plus a positive, what you actually wind up with here is a subtraction problem. And the sign of the greater absolute value is the one that carries. So whatever you have more of, that's your sign. This tells us I have more positives. So what I want to do is find two numbers here that have a difference of 1. And I want to make sure that because this is positive, I give more positives. I give that greater value the winning sign. So doing these negatives can be a little bit tricky. In fact, look at this one that I'm going to give you now. X squared minus x minus 12. The only thing that's different in this whole between this problem and this problem is what? Yeah, it's that sign here is different. So how do you think that's going to change our two binomial pairs? X is still going to split the same. X squared, I have 1x here and 1x here. But check out this 12. I still have a product of negative 12, but look at how my number puzzle changes. Now I have a sum of negative 1. So when I go back to my chart, which number is going to get the plus and which value is going to get the minus sign? Yeah, I have more negatives than positives in this story. So it's fun to think about and play with the signs for sure. Okay, we're going to do one more. All right, here's another quadratic trinomial. And remember, the shortcut we can do when we have a coefficient of 1 in front of it. So step 1 is to do what? You got it. Draw your parentheses. I'm going to split my x's. 1x goes here and 1x goes here. I'm going to draw my number puzzle, and I'm looking for a product of negative 27 and a sum of negative 6. So let's talk about what this means. This negative sign tells me what? You got it. My signs do not match. The only way to get a negative is if I have one positive and one negative being multiplied together. So let's break down 27. We'll draw a factor table for it, and it'll be kind of short because 1 goes into 27 times, 2 does not go in, 3 goes into 27 9 times, 4 does not go in, 5 does not go in, 6 does not go in, 7 does not go in, 8 does not go in. So my next value is 9, so I know I'm done. Because my signs match, I know I'm looking for a difference. So what two numbers multiply together to give you negative 27? And when I add together, I get negative 6. So they'll have a difference of 6. So yes, I see 9 and 3. So I can go ahead and put 9 and 3. So the big question is, who gets the negative sign? Who goes in this position, the 9 or the 3? So when I look here, I see that I have more negatives. So I'm going to go ahead and assign the negative to the 9, leaving the 3 positive. So my 9 gets the negative and the 3 gets the positive. I know I said this was the last one, but let's do one more. It's too much fun. All right, so we have x squared plus 7x minus 44. I went ahead and already drew my two binomial parentheses. I'm set up, ready to go. What's my first step? I'm going to split my x's into x times x. What are my signs going to be? You got it, one positive, one negative. And it doesn't matter which one you write first. You can put the negative first. It doesn't matter. All right, let's do our number puzzle. I'm looking for a product of negative 24 and a sum of positive 7. So as you think about that for a little bit, let's do our factor table. And we have 1 and 44, 2 and 22, 3 doesn't go in, 4 goes in 11 times, 5 does not go in evenly, neither does 6, or 7, or 8, or 9, or 10. So guess what? I reached my wraparound. Again, don't forget, you can always go to your calculator, ask your calculator 11, or actually it's not 11, it's 44 divided by all the numbers in the whole wide world. You can go to your table of values, and there you can see 1 and 2 and 4, and the rest are all decimals. The same job can be done on Desmos too, don't forget. So we're looking for a product of negative 44, and then two numbers that have a difference. And I know that this is going to be a difference because my signs don't match. So when I add them together, I'm actually going to be subtracting. So two numbers that multiply together give me 44 with a difference of 7. There they are right there. And I have to decide which number is going to be in the positive and which one is going to be in the negative position. Because my sum is positive, what number did you put here? You got it. There are more positives than negatives. So my 11 goes into the first spot and my 4 goes into the negative spot. All right, good job today, you guys. Keep on factoring, keep on practicing. You can do it.